Hi, my name is George Dong, and this is my presentation on Lab 2, Charge Tapes, which is the continuation of Lab 1. The purpose of this lab was to obtain a more accurate approximation for charge Q using GlowScript. Now, the fundamental principles for this lab are the same as Lab 1, with Coulomb's law and Newton's second and third laws. Except now that we have the concept of superposition, which states that you can take a larger object and divide it into smaller objects and find the individual charge of each of those smaller objects. And the summation of those charges would be equal to the total charge for the larger object. And for the results, we got electric force obtained with 100 segments was 2.492 times 10 to the negative 3 newtons. And the magnitude of electric force equals that of the gravitational force. Here are some assumptions for the lab. Each tape can be divided into segments that contain an equal and evenly distributed amount of charge. Each of those segments will be considered a point charge, and the sum of each charge from each segment will equal the total charge on each tape. And of course, air resistance is negligible. Just to recap what my measurements and data was for Lab 1, my length of the tape was 0.2032 meters. Mass of tape was 2.54 times 10 to the negative 4 kilograms. My distance between tapes A and B was 0.023 meters. And the gravitational force on tape B was 2.49 times 10 to the negative 3rd newtons. And the charge on tape B was found to be 1.2 times 10 to the negative 8 coulombs. So now I'll talk about my GlowScript code. So this is a snippet from the nested for loop from my code, and I just wanted to highlight that this is a perfect demonstration of superposition because the code in the for loop iterates through each segment and then sums up those respective fields and then replaces the E at DQ top and the FE on top by those new values. So it's just a continuation summation of the smaller segments to equate that new larger total, which is superposition. This is my initial test of the model using my calculated value of the charge from Lab 1, which was 1.2 times 10 to the negative 8 coulombs. And as you can see, the field vector arrow for electric force is much smaller in comparison to the force arrow for gravity. And the goal would be to get them to be as close as possible to each other. So with a lot of trial and error, I managed to get the electric force vector and the gravitational force vector to be pretty close. And I did that by barely incrementing the value of Q until they matched. And the final value of Q that settled on was 2.703 times 10 to the negative 8 coulombs. To recall, from Lab 1 we had Q equals to 1.2 times 10 to the negative 8 coulombs. From this lab, got 2.7 times 10 to the negative 8 coulombs for Q, which is a 125% increase, which is pretty significant. And why do these estimates differ? Well, in Lab 1, we used a method of treating the entire tape as a single point charge to approximate Q. And in that calculation, we only considered the Y components of the electric force. In this lab experiment, we consider both the X and Y components for electric force using the concept of superposition, which would more accurately reflect what we'd see in the real world, because most objects of concern are larger than a single point charge and can be represented by the summation of smaller segments.